The previous chapter of this video discussed the enhancement brought about by Spectro-X version 4 of multi-channel simultaneous viewing of multiple channels of spectrum recordings. And we left it with the ability to not only display multiple channels, but the idea of being able to correlate spectral activity either time or frequency wise across the 2 channels or 4 channels, however number of channels are displayed, using markers and the ability to perform mathematical analysis on those marked channels. So let's take a look first at an application of that marker and marker math capability by looking at how one would go about measuring a time difference of events, spectral events across 2 channels. Here we have 2 channels of linear chirps and some other activity that was recorded. And if we just go ahead and start the recording, because it's playing relatively quickly, it's not readily apparent as to whether or not there is any time difference between the beginning of one linear chirp in the first channel and a corresponding linear chirp in the second channel. So one way to zoom in and see if visually we can at least begin to identify whether there's a time difference, how significant it might be, and whether it's worth measuring or not, is to go ahead and, since we're doing time domain measurements, use the scrolling time domain plots and designate, instead of looking and spanning across a period of time that includes multiple chirps and therefore compressing visually what's going on, let's just go ahead and select 2 chirps, which show up as pulses in the time domain, and tell Spectro-X just to play those 2. When I do that, I now have a greatly expanded or zoomed in visualization in the time domain and correspondingly in the frequency domains of what is going on in these recorded channels. And sure enough, what begins to show up is across the 2 channels, there appears to be a time difference between the beginning of a chirp in channel 1 and the beginning of the corresponding chirp in channel 2. This may be, for example, transmission and the reception of the reflected pulse. So there may be some interesting information here to be derived by how long it took for the transmitted pulse to be received in channel 2. We can go ahead and continue to expand this by looking at just one individual chirp. But even with that, it's very difficult to know in the frequency domain plots where we would place a particular marker, and then how we would go ahead and use that information, that marked information, to help us make that time domain difference. So let's return back to a pure time and magnitude display, enlarge that to the greatest extent that we can across the monitor, and place markers at equivalent power levels. Because the markers are 2-dimensional markers, in this case time and power, and we want to make a time difference measurement, we need to make sure that we are placing the markers at correspondingly equal power levels across the 2 windows. So Spectro-X provides certain tools, visualization tools associated with the markers to make this a lot easier. I'll go ahead and place the first marker at minus 30 dBm, right on the leading edge of that pulse. When I click, I've got crosshairs associated with the markers that extend and span across the entire plot window, extending all the way out to the axes themselves. So it's very easy to see that, in fact, I have placed this marker at a minus 30 dBm power level and clearly at the leading edge of that pulse. But now I want to go ahead and place a second marker in channel 2 at the same power level. So I can go ahead and line it up visually, and when I click, I get verification, at least the beginning of a verification, that in fact they have been placed at the same power level, because the spanning horizontal lines of the cursor, the spanning horizontal crosshairs of the cursors, in fact do line up. But even more quantitative than that is if I now look in the plot marker window, marker number 1 corresponding to channel 1, marker number 2 that I've placed in channel 2, do in fact show that they were placed at the same power levels. But remember, what I want to do now is measure the difference in time between these 2 markers. In this case, again, perhaps a transit time of a transmitted pulse and the reception of the received pulse. And I can do that by going into the math window, telling it to measure the difference between marker 2 and marker 1, clicking on the compute button and noting that Spectro-X has given me the quantitative difference measurement of 10 microseconds between the beginning of the pulse in channel 1 and the beginning of the corresponding pulse in channel 2. I could just as easily, going back here, place a third marker within a particular channel, and notice how the markers, when placed, show up as different colors, so you can designate between them visually very easily. I could just as easily place multiple markers in an individual channel, and there is no limit to the number of markers that can be placed in any number of channels. Once I have done that, I can then use the same process, in this case, to measure the pulse width by noting the difference, or asking Spectro-X to give me the difference between marker 3 and marker 1, and coming up, in this case, again, interestingly enough, with a pulse width of 10 microseconds as well. One other feature while we're on the issue of markers that's interesting is you may have noticed that as I've placed markers in one window, the markers will show up in the other plots as well at the corresponding place based on the individual parameter that is being displayed in both windows. In this case, I've placed markers in a time domain plot that are two-dimensional markers indicating time and magnitude. When I place the marker, it is at a specific magnitude and therefore is placed equivalently at that power level in the spectrogram, because the spectrogram measures, amongst other things, power in addition to time and frequency. It is being placed here in the case of time and magnitude. And in the case of the persistence spectrum, it is being placed at the corresponding magnitude and across a frequency plot. I can also move markers. And as I move those markers across the dimensions within a particular window, the markers are moved in the corresponding dimensions in the other plots for that particular marker and for that particular channel. So you can begin to see that it's extremely easy to be able to use the markers as a visual reference point to designate individual specific details of spectral events, and then use the marker math window to be able to quantify what those differences happen to be.